Section 1.1 is about relations and functions, and this should be a pretty good review of your Algebra 2 days. First off, we're starting with some prerequisite skills. I'm going to assume that you know how to evaluate functions or any type of equation I give you for any type of value of x that I give you. You should be able to plug -3 into everything and evaluate. So -3 squared minus 2 times -3 minus 5. We do the exponents first. -3 squared is going to be 9. -2 times a -3 is a positive 6 minus 5. This is 1. 9 plus 1 equals 10, right? Should be easy enough. Again, plug -3 in for number 2. So 5 times a -3 divided by -3 squared. We do what's on the top first and then do what's on the bottom. So we have -15 over a positive 9. Sorry, there's a negative sign out in front of that. So we have a negative and negative makes a positive. So we're going to have a positive 15 over 9, and then we can reduce that. We take a 3 out of both of them, so we'll have 5/3. All right. With 6 here, the square root of 6 times -3 plus 34. 6 times -3 is -18 plus 34. So the square root of -18 and 34 is going to be 16. The square root of 16 is plus or minus 4. And last one, the absolute value of x minus 4. So we can say the absolute value of -3 minus 4, which would be the absolute value of -7. We know absolute value is the distance away from 0. So our answer for this case is going to be 7 when we evaluate. So hopefully that was pretty easy. This is kind of the prerequisites I suppose we need for this chapter, or for this section. First of all, now getting into what our section is, a relation. A relation is a set of ordered pairs. The domain is the x values, the range is the y values, and a relation can be any ordered pair, anything. For every x, there's a y, and it doesn't matter what kind of x's and what kind of y's we have. All right. So one of the bigger things that for some reason a lot of people struggle to pick up on is the domain means you're looking for our x values, and the range means we're looking for our y values. So, example 1, if x is a positive integer less than 6, state the relation representing the equation y equals 5 plus x by listing a set of ordered pairs. Also state the domain and range of the relation. So they tell us what x is. Positive integer is less than 6. So that means it's going to be 5, 4, 3, 2, 1. All right. State the relation of ordered pairs. So if those are our x values, we better figure out what our y values are. So when x equals 5, y is going to equal 10. And how did I get that? I plugged 5 in right there and evaluated. So my relation is going to go in a bracket like here. When x equals 4, when I plug 4 in, I'm going to get 9. When I plug 3 in, I'm going to get 8. When I plug 2 in, I'm going to get 7. And when I plug 1 in, I'm going to get 6. All right. And notice they said integers. Integers are whole numbers. In this case, they listed positive integers, so that's why our x values are only 5, 4, 3, 2, and 1. They said also state the domain and the range. All right, so the domain then is going to be our x values. Domain is going to be 5, 4, 3, 2, 1. Our range values are going to be all of our y values. So 10, 9, 8, 7, and 6. And we put them in little brackets here to note that they are set. Okay. Example 2, why don't you do that one in your notes by yourself, is where you hit the pause button. Do that in your notes by yourself. If x is a negative integer greater than -4, if x is a negative integer greater than -4, state the relation representing the equation y equals x squared minus 5. Also state the domain and range. All right, so why don't you hit pause, do that one on your notes, and we'll check that in class. Now a function. A function is a relation in which each element of the domain is paired with exactly one element in the range. The same x value cannot have a different y value. So if I got a list of ordered pairs, if I have a ordered pair 3, 5, If it's a function, every time I plug 3 in, I better get 5. If it's not a function, I can plug 3 in there and I can get like -5. Or I can plug in 3 and I could get 10. And I could get different answers for my y value. That's a relation. The difference between a relation and a function is that a function has one exact y value for every x value that you have. So if it is a function, if I get 3, 5, every time I plug in 3, I better get 5. And that's what it means to be a function. Every function is a relation, but not every relation is a function. So every function is a relation because they're a set of ordered pairs. They have a domain and a range. But not every relation is a function. Not every relation has the same y value for each x value that you have. Okay? So here we go. Is the following a function or not? Well, first we better look, is there any repeating x's? Nope, there's no repeating x's, so therefore we must have a function. Look at B. There are any repeating x's. Looks like there's repeating x's here. One time we plug in 3 and we get 2 for y. The next time we plug in 3 we get 4 for y. Therefore, it's not a function. Okay, that's not a function. All right. When we have a graph, it's very easy to tell whether a relation is a function or not by the vertical line test. All right, I know for a fact now that I teach algebra that you had this in Algebra 1. Okay, if it's a function, a vertical line drawn anywhere on that graph will only pass through that graph one exact time, because that tells you that you only have one y for each x value that you have. But if it passes through it twice, that means you're going to have different y values for a specific x. And I'll give you an example right here. We're asking, is this a function or not? Well, if we use a vertical line test, if we draw a vertical line any point on that graph, and that vertical line only goes through that graph one time, kind of ran off the page here, it only goes through this graph one time, then it has to be a function. If I were to have some graph where it wouldn't, where it would pass through it twice, like say maybe I had a graph like this, and that's just a square root graph, and we'll learn more about that in a little bit. But if I draw a vertical line, and even if it's just one spot that it crosses twice, it's not a function. It's a relation, but it's not a function. This, not a function. The one up above is a function. Okay? So, a function is denoted by the letter F for function. Fx, so this notation right here is read f of x, meaning that the equation is a function in terms of x. So we could have f of s, we could have t of s. Well, basically what's inside of this parentheses is tell us what the independent variable is. All right, so what the equation is written in as far as what the independent variable is. All right. So when we're using function notation, this now is saying find f of -1. So instead of there being an x in the equation, anywhere we see an x, we're going to plug -1. The function at -1, the function of -1. So this is anywhere we see a -1 or an x, we're going to plug -1 into it. So I have -1 cubed minus 1. -1 cubed is -1. A negative times a negative is a +1 minus 1 is 0. So f of -1 is 0. And what we have there is we have an ordered pair, -1, 0, because -1 is my x value, the thing I plugged in for x. My output, my y value, is what I got when I plugged -1 in, is my 0. Okay? And that example 5 you can do in your notes by yourself as well, and we'll check that in class. Make sure you understand. All right? Okay, a lot of times we'll be given the equation of a function, but they won't give us the domain. In most cases, the domain is all real numbers, but there's certain times where the x values make the equation undefined. So if we make the equation undefined, it can't be in our domain of our graph. It can't be an x value. And how we make our equation undefined is, you guys know that you can't ever in a million years divide by 0. All right? We can't divide by 0. So they're asking to name the values of x that are not in the domain of f. All right? So there might be a value that we can't have in our domain. So this might be all real numbers except, one value or two values or three values, whatever. But what we know is we can't divide by 0, so we know that we can't have 0 in the denominator. So x squared minus 5 cannot be 0. If we add 5, x squared equals 5. And take the square root, so x equals the square root of 5. If we plug the square root of 5 in for x, we would get 0 on the denominator. And that would make it undefined. So the domain for this function a would be all real numbers. I denote it as ARN, all real numbers, except x equal to plus or minus the square root of 5. Sorry, when you take the square root, it should be plus or minus. Plus or minus the square root. So there's two values there where my x cannot be it, so they can't be in the domain. For b here, the square root, we know that if we take the square root of a negative number, you learn this in Algebra 2, if you take the square root of a negative number, you're going to get an imaginary number. And imaginary numbers we don't graph, we don't deal with. All right? So, when we're talking about the square root of x plus 1, what values are going to make that square root negative? So, basically we're saying that we can't have x plus 1. This cannot be less than 0. So x, if we subtract 1, is less than negative 1. So any value that's less than negative 1 is going to make that equation negative. Does that make sense? So we can't have a negative down here. That's why I said that that this cannot be less than 0. This less than 0 means that we would have a negative value, right? So if I put that less than 0, anything less than 0, negative 1, negative 2, would be negative number. So when we say that x cannot be less than negative 1, if I plug negative 2 in here, the square root of negative 2 plus 1, the square root of negative 1 is an imaginary number. We can't graph imaginary numbers. They're not on a graph. So we say that the domain would be everything that's got to be greater than or equal to negative 1. X is greater than or equal to negative 1. It can be 0. The square root of 0 is just 0. But it can't be anything less than negative 1. Or you could say the domain is all real numbers, or you could say the domain is all numbers bigger than, or negative 1 and bigger. You can write it any way you want. This is how I write it. X is greater than or equal to negative 1. So it's got to be bigger. If I plug 0 in, the square root of 0 is, or 0 plus 1 is the square root of 1, which would be 1. So you can't have it negative. You got to figure out what would make your equation negative if you have a square root. All right. Again, in your notes, this is your time to hit the pause button and try those two, trying to find the values that x cannot be. And if you have questions on those, please come and ask me. I'll attach another video as well as Khan Academy, a good guy describing a good lesson, describing functions on graphs and functions written out in ordered pairs. So just another resource for you to help you on the subject. That's all I have for you. Here's your assignment. It'll be posted on the website as well. See you in class.